So I want to just welcome everybody. Hello. I want to introduce myself. My name is Ron Frizard with the A.w.Chesterton company. I'm being joined today by my esteemed colleague, Cameron Rappaport. Say hello, Cameron.
Hello, Cameron.
And
It's the oldest joke in the book.
yes, it's a good one on a Friday afternoon for sure. Just a quick thing about myself. This is a quick little bio. I really want to just say I've been in this business now 25 years, done a lot, almost all those years focused on valve packing and pump packing. And today we're really going to focus on a topic that we hear an awful lot about, especially with new regulations that are coming down through the EPA and other legislative actions. Matter of fact, I was just in Canada a couple weeks ago, and they're very interested about sealing what we call LowE emissions. And this is a presentation today. We're going to go over LDAR valve installation techniques, which is, just in case no one knows that acronym, that's leak detection and repair for LowE valve packing, which typically means below 100 parts per million. Now, the first thing, I go to a lot of these conferences, I talk to a lot of people, and the LDAR market has changed drastically. One of the big things it changes is on software. So a lot of times they're selling new software packages on how to manage these leaks. And one of the most interesting things we saw recently is someone from the EPA came up to our booth and they said, you know, it's really important to manage leaks, but I really wish they would start, using technology to focus on stopping the leaks before they have to be managed. And it's just a really good quote that I say often, because so many times you'll see people talking about software much more than they talk about actual technology like valve packing and installation to actually stop the leaks before they have to be monitored.
Yeah, this is actually part of a larger trend throughout the entire process industry towards more predictive and scheduled maintenance instead of being reactive. So this is just one example of across pumps and valves and basically all equipment where people are trying to get away from that reactive maintenance, just fixing things because they're broken, and trying to predict and get ahead of them and schedule things.
Oh, for sure, for sure. And it's amazing too, because it comes down to a lot of times with valve packing, it's just the technique on how it's installed that means so much. So, which we'll talk a lot about today, which is good practices on installing packing correctly. So one quote that I do like a lot here is this one from Voltaire, where it goes, "Common sense is not so common." It's amazing how many times I've seen people install packing without really thinking what's needed. And if one of the most important things you can realize is that one of the best ways to lower your overall leak rate in your plant is to really focus on installing correctly. If you overlook the installation step and don't put time and effort into it, you're just going to end up paying on the other end, because valves are just harder to seal without it. For example, one of the most important things over the last 20 years to get leak rates down so much is to make sure the packing is sized correctly, installed correctly. We have the right valve measured correctly, so the packing goes in there. All those things we're going to talk about today, but one of the most important is spending time and effort in that installation step and not rushing it, which I see a lot.
Yeah, I'd say a lot of the new packings, especially the kind that you're going to put into LDAR applications, is much denser than it used to be. It can be a little harder to install because of that density. And because of that density, as you compress it, it's not going to give quite as much as you would in say, a valve packing that you might be using to seal plain water or things that aren't at 700 degrees or thousands of psi.
Oh yeah. I mean, into you can't treat all packing the same. I mean, each packing by their manufacturer's recommendation of load is important to know and then install it to that procedure. You're exactly right. The same loads that you put on most packings to seal 500 parts per million is not the same load you need to seal on 100 parts per million level. And making sure your people are trained well to install and to follow that procedure is really where the headache can go away for this issue. And you don't have to do that much on the less on the backside, which is to have to pay the fines or have to pay to shoot a valve with valve repair online. And once again, just to requote myself here, time and effort during valve packing installation is the best chance to reduce LDAR issues. I think it can't be stated too many times. Another example is in the upper right-hand picture there, cutting the rings. How crucial that is, and we'll talk about it in a minute, but I've seen people cut terrible rings and they just don't install very well. Same thing about tamping rings into the stuffing box, properly consolidating. We'll talk about all these things. So let me go to the next slide here. I wanted to give a quick overview about how much this industry has changed over the last 15 years. Early on, before 2000, one of the major issues we had is each packing manufacturer pretty much had their own protocols on how to seal emissions. And that would include the media. Sometimes it was, some people would mix methane in a 50-50 ratio with other gases that weren't as small, especially nitrogen. Some people would test in 100% methane. And there was all this different levels of cycles, how many cycles to test for, how many, what pressures. All of these issues made it very hard to compare and really move the ball forward on sealing emissions based on packing because of that. Starting after 2000, a lot of things started happening where refineries started to create their own protocols and said, okay, I'm tired of looking at 10 different types of tests by packing manufacturers. Here's a standard type test, and we want you independently to test to them. It was about 3 or 4 of them, and they all kind of had certain differences to it. And it wasn't really until after 2006 did standardization start taking over, where we really had like the API, TA Luft in Europe, and the ISO standard really started to come together and get these protocols together in one piece.
Yeah, so we're actually going to talk about this more in a future webcast that we're doing in a couple of weeks. So stay tuned for that. And one of the valuable things with the industry is that if you participate in things like the API, you see that these are going to continue to evolve. We have API 641 coming out soon, which is going to be the same standard for quarter turn valves. Mm-hmm. So really from both an industry regulation, so some self-regulation, as well as the governmental regulation, these are only going to keep increasing and get stricter and stricter.
Right, exactly. Hold on a second there, I went too fast. These are really the 6 things that I think are crucial when it comes to in measuring to LDAR valve installation. They include measuring the valve correctly, 2 would be the inspection of the valve. 3 is actually doing the installation of the packing. The fourth one we'll be talking about is consolidation of the packing set. And then some of the bigger trends to enhance the whole system is something like having a continuous improvement of the process. And then we'll talk a little bit about training too, of how critical a part that is to make sure people know how to install, to be able to do these other steps correctly, to make sure we get the right program in place. So let's start right off with the first one here, which is measuring. Today, we run into this problem a lot where people don't actually have the dimensions of the valve in front of them. They have looked and they've eyeballed it, or they've taken the packing from the before, like they might have taken the packing out and said, "Oh, I'll use this as a guide," and it might have been measured incorrectly. Without correct dimensions, we're in trouble from the beginning. And the other issue is recording those measurements is vital. I've run into many people who don't put them in one place, and that they have to constantly remeasure the valve over and over and over again. I really run into that problem a lot when the valve is in their shop, or a new valve has come in and it's very accessible, and they never actually take the dimensions until it's installed, and then it's very hard to get those dimensions. So recording dimensions is important. Now, I get a lot of people also say, well, Ron, especially young engineers will say to me, well, I have the drawings from the OEM. I don't have to worry. It has all the dimensions on there. And that is just a fallacy. We see many a times where most OEM drawings don't even have stuffing box dimensions. If they do, a lot of times their tolerances might be so wide, or the valve those dimensions are only for reference only, and the valve won't even meet those dimensions. So it's real critical to actually have someone who knows how to measure pretty accurately and get those measurements. And as I said, getting them and keeping them in one place. The story I have about this is, someone was really into this, and they were measuring, and they used yellow stickies, and they put all the dimensions into a folder that they had measured, and then put the folder away. What ended up happening is 5 years go by, and they have to go and look to order new packing, and there's no idea where that yellow sticky is. That guy has moved his files. It's all over the place. Having a software program using even Excel or anything like that is very helpful, because you can actually keep all the dimensions in one place. What actually do you measure? I run into this a lot too, and it's really not that much stuff. These are really the critical pieces that we like to see being measured. One, of course, is an identification of where the valve is, what type of tag number it has, so we can reference it. Many people have different tagging systems, but if the valve's in an LDAR system, an LDAR program, usually there's an LDAR tag. That's a good one to use, so we can identify that valve. We also like to have, as reference and backup data, is something like who the manufacturer is, what the model number is, what the size of the valve is. It's also a good reference, so when you want to do any statistics or running data, it's good to have that type of information also on the valve. Now, on the packing side of it, some of the main things we need to know is a very good, accurate measurement of the stem. Actually, this is the stem OD and the box ID. The ID and OD screwed on that, but it's very important to know the exact dimension of the stem and the exact dimension of the inner diameter of the stuffing box, because that's going to tell us what cross section of the packing goes in there, and it's very important. The one following after that is the stuffing box depth. This is going to tell us how many rings we need to put in that stuffing box. And remember, a lot of times, about 30 years ago, there was a great study done on valve packing performance in relations to how many rings are in the box. And it was determined back then in vivid data that only 5 rings are needed. But we still see today a lot of valves that are deeper stuffing boxes, as much as 8, 10 plus rings. And really, to get to LDAR performance on valves, we really have to shorten that stuffing box. And one thing we'll need to know is what the entire depth is. Now, because most manufacturers of packing today for LDAR will be using a torque value, it's going to be important to know the stud diameter and the number of studs. This is crucial because that's part of the torque calculation based on how much force is actually going to go around that bolt that we're going to apply that torque to. Next on this list is the gland nose length, or sometimes called the gland follower length. We're talking about the pusher that is actually going to go into the stuffing box before it is flush and can't put load on the packing set anymore. That's a very important dimension because different valve manufacturers have a wide range of how long that gland nose is. And it's really important to know that so we can actually calculate out if we're going to have a problem in what we call bottoming out the gland. Sometimes we actually have to put another ring because we're going to balance that by how much compression we get on the packing set. And then the last thing is very important is what is the operating condition of the valve. We're talking about temperature and pressure in media, and those are the 3 factors that any packing manufacturer would want to just double check that their packing fits within that criteria. So Cameron, you've done most of these. You know what I'm talking about?
I do. There's only one other thing I'd like to mention. It's not something I don't think you need to measure every single time, but something that's very important and can really affect how your packing seals, and that's surface finish.
Yep.
Yeah, so especially for very low parts per million, if you're trying to go under 100 in particular, we recommend very fine surface finishes, so RMS of 32 or lower on the actual valve stem. And that also checking that'll help you figure out if maybe your packing is failing because of some stem corrosion. Maybe you have some electrolytic corrosion going on if you're using a carbon or a graphite packing.
Yes, I think you're slightly ahead when we talk about inspection, but you're absolutely correct. But you'll be doing it at the same time, right? Because you're going to be, when we're measuring, we're also inspecting. So let me jump there right now. One more thing. Let me talk about accuracy of measuring, which is, accuracy of observation is equivalent to accuracy of thinking. It's an old quote regarding how people perceive accuracy of measuring. There is a little bit of training that can be done on measuring correctly. I think it doesn't need to take too much time, but I've seen people use verniers very, let's say, non-trained. They can be off by quite a bit. Measuring a stem and metal surfaces and how to handle a vernier takes a little bit of, as I said, a little bit of training. And regarding calibration, always important to make sure any type of measuring device has been calibrated to within a certain quality standard. And it's amazing how many times I see uncalibrated measuring devices out in the field. Very important. But let's jump to inspection, what we were just saying. The first part, before we get to the actual inside the stuffing box, one of the first things we want to do is check the dimensions to what we thought it was. So for example, sometimes you have packing someone had already measured that valve previously, and you have brought the packing for that valve. In that case, you're going to check those measurements and make sure that they match up. Sometimes there's been a mistake done upstream and the dimensions don't match the actual valve. And it's real important to have another set of eyes to do that final dimensional check and get that fixed. Confirming the depth of the stuffing box. Sometimes people have only measured to where there is a maybe they have an old ring that is stuck in the valve stuffing box that hasn't been all the way removed. I've seen that before where people say, oh, the stuffing box depth is 3 inches, and then someone goes to actually go install it, and they look, and there's actually some rings in the bottom of the box, and they have to take them out and get it, and then they'll end up with a new depth. Leaving old rings into the stuffing box is not a very good idea. One of the main things it will do is it will suck up gland load because it will slowly consolidate over time. It also can cause higher friction because it's adding more stress on the stem. So getting all the stuffing box, all the rings out is very important. Another important thing is the bolts and the condition of the bolts. As we were talking earlier this morning, I was presenting here in a nuclear conference here in New Orleans, and there was a presentation given by a nuclear plant, and they were having packing issues. And one of the first things I noticed on the slide is they used the old studs and barely cleaned them up and then reinstalled the packing and got the same results. And I had to bring up this whole idea of how bolt and damaging of the threads and not getting an accurate gland load based on torque when the bolts are damaged. For LDAR, how important it is to make sure we get the right torque and load. Remember, those are two different things, but torque can, based off of the coefficient of friction and all those things, give us that load. And with bad bolts or bolts that are damaged or old, it's very hard to get an accurate loading in the packing set. We really, if it's an LDAR valve, really consider replacing the studs to get so we get an accurate load on the gland set. We're talking about the packing now. So one of the best chances to see what's going wrong with the valve is looking at the packing as it comes out of the box. I've run into people time and time again and say, oh, this packing has failed. And I said, well, did you hold on to the packing so we can do a failure analysis? And most of the time it ends up in the trash. I really am a big fan of using a plastic bag as part of their quality system, where they actually store the rings and bag them and tag them so that we can evaluate what might have been going on. Is it a packing problem or is it a valve problem? Because we can also look at things for extrusion. So if there's a bad clearance on the bottom of the box or a bad clearance in the top of the gland. Many times I'll see people have used the wrong cross-section because it was an installation issue where someone mismeasured, or they tried to, they just might have not had the right size cross-section packing and they tried to put it in there. Another thing we can see is cutting of the ring. You can see how quality of the cut of the ring was done before, if the ring is too long or too short. And then sometimes I've actually seen where there's a warehouse or miscommunication issue and people have installed the wrong packing in the wrong application, and they can't handle the temperature or the chemical compatibility of it. So another very important thing to look at is as the packing comes out of the box. So Cameron, I told you it was in here.
Yes.
As the first thing, as I mentioned earlier, is that gland nose length and how critical it is, because we do not want to bottom out that packing. And what Cameron said earlier, for sure, is very important, is the stem finish and also the outer box finish. I probably should have added that in here. I get a lot of people who say, "Oh, that's awful hard to do." You know, everything's hard to do. It's putting time and effort into training and procedures to be able to handle that. In that picture right there, that is a pocket stem finish guide. I've seen them made out of plastic for very short money. I've seen them made out of metal for a couple more dollars. A good installer packing. It's really to have that. It's nice to have that with them in their kit, and they can use it as a comparator to see what the stem finish is on the stem compared to that gauge. There's also electronic equipment that we can use to put right on a surface, and it will also tell you what the stem finish is. Do you remember what that's called, Cameron? You seen that thing?
Oh, the electronic surface comparators. I don't remember what that's called.
I think that's actually probably what I think it's called. But we have one in the lab, and I know when we're looking at valve parts, we use it there also. And I've known people to use it in the field. It might be a little hard if the valve's in a tough location, but surely in the shop, if you had a chance to actually have the valve fully apart in the shop, it's easy then to do a quick check and get what the stem finish is. And the reason that's important is different packing manufacturers have different requirements to seal based on the stem or the box finish. If it's too small, sometimes there's a problem, and if it's too much, it can also be a problem. So there's a certain range that each packing manufacturer will have that they want the stem finish and the box finish to be. This last thing here is for angled valve bottom of the stuffing boxes. Also checking for the angle on the gland. Usually they come in a pair. This is a real big problem because depending on the packing type that you're using, it's designed for either an angled stuffing box or a flat stuffing box. My experience is that most packing for LowE that I have seen is all square packing, and it's designed for a flat bottom. And if the valve that you're trying to get LowE performance out of, you'll have to retrofit it to make it a flat bottom of the stuffing box. One way to handle that is using a bushing or a junk ring at the bottom of the box to kind of make it flush. But it's really important to not have that angle in the bottom of the box.
Sure. The only other thing that I'd mention is that not all valves are created equal. So just because you have packing that is rated, say it can do under 500 parts per million or 300 or 100, that doesn't necessarily mean that it can do that in a particular valve. So if you're looking for under 100, you might want to look at API 628 to 624 valves. And it's not just the stem finish or the finish on the stuffing box, but things like if the gland is too flimsy and that can't take the load, those could all affect how your packing will work in an individual valve.
Right, right. And another point is I've seen valves, like people have brought in 3 valves from one valve manufacturer, and they were LowE, right? Or at least they had tag on them that were all LowE. But all 3 of them had the same model number and same size, but all 3 had different dimensions for the stem and the box. So, it goes back to that idea that, measure, make sure you have the right dimensions because even that can change even between the exact same valves. And you're right, the API 622, and really, you're talking more about the API 624 changing, right? That we're still in the first couple years of that, and that's really changed the game a lot, as you said, because now people are getting a lot of different feel about how valves are designed much better and has gone through some testing that it can actually perform to LowE conditions. That's a very good point. see here. I think I mentioned this a minute ago, but it's always a good point. Today, going back to that report in the EPRI report in the mid 80s, more than 5 packing rings is actually going to hurt sealing and not help it. So this goes back to one of the main things of when we're measuring a box, the stuffing box of the valve, how deep it is, and retrofitting it to just 5 rings. This really can cause all kinds of problems. Besides being able to not transfer load through the packing set very well, it also, this consolidation of those many rings can cause us to eat up the gland nose and cause it to bottom out sooner. The best way to retrofit them in the industry is using a carbon spacer, which is much better because it has a lower thermal growth rate. Some people early on were looking at using metals to make this stuffing, to make this retrofit in the valve. And the question was, do you make it out of the stem material or do you make it out of the valve body material? And you have to be very careful on the thermal growth rates of what that spacer, if it's made out of metal, could be, because if you miscalculate the tolerances, it can actually gouge the stem and actually lock up the valve at elevated temperatures. Carbon, one of the nice things about carbon spacers is if it's rubbing against the stem, if there's any side loading or thermal growth issues, it will actually wear before you cause any damage to the stem and won't lock up the stem at all. So, bushings, that's important. Cutting rings. The first thing is nice to know is that if there's the best solution by a long shot is to have rings already cut by the manufacturer. It really takes a large burden off of the maintenance and the maintenance personnel to cut rings. Cutting rings can add a large percentage of error when they are installing those rings. It can be done for many reasons. The ring can be too long, the ring can be too short, it can be not cut properly and it starts to unravel if it's not properly cut. If you're going to cut your own rings, it's important to have a good amount of training for those people. And just to go over a few of some of the points that I think is important when you cut those rings. One is use a mandrel. I think is much better than any type of tool to cut packing rings. It actually causes the stress of the packing ring as you bend it around the mandrel to settle out to the size of what the stem would be when you cut it. So the length is actually a lot more in relationship to the stress of putting it into the stuffing box. So that's number one, cutting using a mandrel. Number two is using a sharp knife. Most of these materials are going to have wire in them and some graphite material, and trying to cut packing with a slightly dull knife really destroys the packing ring and actually creates a lot of voids and a much more non-clean cut, so the ends don't come together very well and it will cause a leak path. I highly recommend to sharpen the knife on a regular basis, usually before you do any cutting of rings, is to sharpen it. I was at a customer recently and I said, how often do you sharpen your knives? And they said, oh, we have a sharpener, and it took them an hour to find the knife sharpener in the shop. So obviously they were like, I guess you're right, we don't sharpen the knife very much. So very important to sharpen the knife. Couple more things. Use a forceful cutting motion. Any cutting show any show you've seen on the cooking channels, you can see how using the knife at a right angle and really putting a lot of force, you should be able to cut the ring in one swipe. You do not want to hack the ring and keep on going back and forth with a parallel motion. This causes the packing to, once again, starting to fray up and not not have a clean cut. Excuse me. Cut each ring separately on the mandrel. Wrap one ring, cut it, wrap it, and cut another ring. Not trying to cut them all at once. And you really want to check each ring afterwards with the mandrel. Doing that, it's like a go, no-go gauge for you. You want to make sure that after you cut it, you then take it and you wrap it around the mandrel and you see how well those ends come together. That's going to tell you if the ring is at the right length, if it's not too short or too long, based on the stress, as I said, when you bend it around. It takes practice. It takes a lot of practice between cutting different types of materials. Some people are used to cutting a much more looser braid or a different fiber braid. It will take them a couple of rings to figure out, oh, this one I have to pull tighter or looser to get that ring properly cut. So if you're going to cut your own rings, make sure the training is in there and that people understand how critical it is to getting that valve to seal by cutting properly.
Sure. I think there's only one thing I want to add to this, and it's about knife sharpness because it's something I'm a stickler for, both in my kitchen and when we're talking about packing. And it's that when you think you have a knife sharpener, you might not actually have a knife sharpener. If it's just one of those things where it's got kind of an X of a metal or ceramic and all you do is just pass it through a few times and you think it's sharp, a lot of times those are honers or they're just terrible sharpeners. So you want something that's actually going to remove some material on a knife because that's how you're going to create a new edge on it. That's something you're going to want to do fairly frequently. And you can get a pretty cheap knife sharpener. You can probably even get maybe your shop to do it for you on a belt sander.
Yeah, this one here, the one we have in our lab and the one I have the picture here of, has a rotating blade in it, and you plug it in. Works really well, but you're absolutely right. You have to remove material. Having a good grinding wheel on it is very important. And I'm talking cheap too. The one we got, I think, was like $25 at Kohl's, and it's not even an industrial an industrial sharpener, but it gets the knife very, very sharp. And having it accessible, and also going back to the mandrels. These mandrels can be out of metal, but one of the easiest things is to have these mandrels made out of wooden dowels. So once again, people are like, where do I get mandrels at? At Home Depot, you can usually get a good common size of most stem sizes out of wooden dowels in an aisle in Home Depot. And once again, if you had special sizes that you would need when you measure the stems in your plant, you can machine down those wooden dowels pretty easily. But having that equipment is really important.
Yeah, just replace those dowels once you really start hacking them apart.
And I think Charlie makes a really good point here is that it is not, she says she will not be cutting her own rings, thank goodness. And it is not very easy to do. The easiest way to handle this is really get the rings pre-cut. Because what you end up having here is really good experience that it takes to cut rings properly, and then really good experience to install the rings properly. And when you make mechanics do both, it's harder to get that experience level high on both pieces. So being able to supply the rings already cut, that takes all of that risk out of that issue. And then you're only left with focusing on just installing the packing rings. So,
yeah,
very good topic.
Yeah, you spend all this time measuring your valve to, a tenth or a hundredth of an inch or a thousandth of an inch. Your packing being off 2 millimeters, that's a lot. So take the time or get cut rings.
Agreed. So let's talk about the next step. So once you have the rings cut, now we're actually going to install them into the valve. This would be after we have the bushing into the box. So now we're only talking about the 5 rings. And really, another mistake I see an awful lot is when you're installing the first ring into the box, all people do is then take the gland nose and push it down and then pull it out and put the next ring in. And what happens there is you don't get that first ring seated all the way to the bottom of the box or to the top of the bushing. And because the gland nose is usually not 4 or 5 cross sections long, it's usually like 2 to 3 rings in length. So what you'll need to do is using a tamping tool, which can be of almost multiple things. Chesterton makes one that's out of plastic. People use cardboard. People can use a lot of things. It doesn't really have to be too high tech. All you need to do is put something that's flexible in there to when you push down the gland, you actually seat the ring to the bottom of the box. And that's really only the first 2 rings that or 3 rings you have to worry about that. Only until when you push down the gland, you're actually hitting solid material. Really run that into I run into that problem a lot because it's an old habit of just thinking it's very easy to install packing rings. And as I said, if you're talking about LowE performance, all of these critical things come to the forefront, and old habits and lax maintenance practices really can hurt you because the valve won't be in LDAR compliance if not installed properly. Another thing, to get LowE performance, a lot of times these packing rings are designed much more dense than regular packing rings, and sometimes sized harder, much more tighter tolerance than regular packing rings. So it's sometimes a lot harder to get the ring into the stuffing box if it's a tight tolerance. So another thing to look at when you're installing the packing rings.
Yeah, I have just a couple things to say on the installation portion. One is that as you put the rings in, you want to make sure that you stagger the splits.
Yes, very important.
Yep. So when you put one ring in, there's going to be a split. You know, say on this side, the next time in, rotate it 90 degrees, put the split there. Next time, rotate it 90 degrees. That's just to eliminate any possible leak paths. The other is that if you're making your own tamping tools, make sure they're softer than the metals that your valve is made out of. Because sometimes people will say, well, I have this steel pipe that's exactly the right size. I'll just cut off a little portion and I'll cut it in half and I'll use that as a tamping tool. You can scratch up your valve stem or the box, and then that's bad. Yeah, I think that's basically it. Oh yeah, and so you see some people they'll roll their packing. Mm-hmm. So not necessarily recommended, but if maybe the box is not quite in tolerance and it's a little small and your packing needs to be just a little bit thinner, so you can actually use basically a rolling pin to roll out that packing. And what some people do instead is they'll hit it. So don't beat on your packing with a hammer to try to make it smaller. Ideally go and get packing that's the right size. But if you really need to do it out, roll it out smoothly. There are all those Inconel or metal meshes in there, and you're going to start breaking that up. You're going to start breaking up the actual packing material when you're hitting it. So try to be gentle.
I couldn't agree with you more. Hammer is not needed in installation of packing ever. And agreed too, very, very good point about metal. We're always trying to keep that stem and that finish of that stem in perfect order. So that would also go with when we're removing the packing. We're very careful not to score or damage the stem, which can start corrosion and intergranular um, uh, chlorine corrosion. So we want to be very careful about doing any stem damage with that. I have seen when we get to really large valves, sometimes people actually take PVC pipe and remachine them so they can use it as an ID and OD. Not an ID OD, but as a tamping tool on very large valves. So I've seen people do, once again, no metal, and they're very careful not to damage it. But using a tamping tool is really critical, especially when you get really large valves. And we want to make sure they're all seated, but actually correct. We don't want to damage them and put any type of a metal on there. Very good points. Let's talk about another area that is sometimes overlooked. So we started with making sure we install the packing rings correctly, cut them correctly, install them correctly, and now the third step, which is tightening the gland studs correctly. And all three of them are very important in their own right. Each one can kind of screw up the overall success of this valve if there's mistakes made. So this last one is using as we said earlier, good studs or even new studs and nuts, and using a hardened washer. And another thing is what type of anti-seize we use and what is the coefficient of friction of that anti-seize. There are a lot of different anti-seize on the market. Your plant is probably standardized on one, which is great. Just make sure that when you're calculating out a torque value for that valve, that they're using the coefficient of friction from the anti-seize that you're using. I was once again, at this conference I am at this week, I saw someone give a presentation, and they were using a table that was published many, many years ago as a standard torque table for flanges. The problem with it is that table actually used a different coefficient of friction than the anti-seize that they were using at the plant. So they didn't get the right load onto the actual flange. It was a flange in the case. Here, it's very important that the torque value is calculated with the coefficient of friction of the anti-seize you're going to use. Hardened washers. This ASTM F36 is a really good reference for the types of hardened washers and the sizing of that hardened washer. Very important to use because if it gives it a smooth surface that the nut will ride on, and it will also keep it from having any type of bending or anything else that could cause a damage between that critical area on the torquing between the nut and that flat washer. So bolt lubrication, how it's put together, and using hardened washers are very, very important.
This goes right back to what Ron was saying earlier about making sure that everything's in good condition, your nuts, your bolts. Maybe you want to replace those studs, because when all these these K factors which you're using to calculate torque, those are experimentally derived using brand new nuts, brand new washers, brand new bolts, studs. So if any part of that equation changes, then it's going to throw everything off.
Exactly correct. Exactly correct. Very important. Torquing. So now you've lubricated the bolts correctly. You put the right hardened flat washer and you lubricate the top of that. You put the nut down. Now you're going to tighten to a torque value using a torque given to you by the packing manufacturer. Very important because the torque is not the same from packing to packing. You want to get it from which packing that you're using. You also want to use a calibrated torque wrench. As I said, important about using tools that are calibrated. Torque wrenches are notorious after a year or two to really kind of wander in their range of accuracy. So it's very important to get them calibrated, I would say at least on a yearly basis. Now, seems simple, but simple steps are important to mention. It's important to alternate the torque on both studs. You do not want to cock the gland. It's a very, I've seen major power plants and nuclear plants and refineries that have come down because someone had thought they had put the right load on a gland, but instead that gland was cocked and the load was never being transferred to the packing set. So making sure using a measuring tool to make sure that the gland is going down evenly is a very important step as you're tightening. And another thing is if you cock the gland, you can actually start scoring the stem, which is another very poor thing that we don't want to do. Now, one of the most crucial steps that is relatively new in the last 15 years or so is the consolidation step. Um, Very important because based on the cross section of the packing and how much and how tall the packing set is, it will actually compress and seat when you first tighten it down. But when you first start moving the stem, they will start moving still and still are consolidating, still creeping, if you would, into getting into the right load. The best way you'll notice this is after you stroke the valve a few times, you'll notice that when you go back to re-torque it, the stud will rotate a couple of flats. This is an indication that the packing is still consolidating. What you'll do is you will re-stroke the valve again and again and do this retightening step until there is no movement of the stud. That is saying that this packing has been fully consolidated and is seated with the correct seating stress to create that sealing. Important note, the larger the cross section, the more critical this is. So with larger valves, it's a very big step. With smaller valves, the number of strokes are usually a lot smaller because the packing consolidates less because it's smaller as an overall gland travel.
Yeah, the only thing I'd say is if you're really having a problem with this, you might want to look into live loading, which is something I don't think we mentioned in this webcast. But if you want to get into packing live loading, what that is and how it can help you, you can drop Ron or I a line, and we'd be happy to talk to you about that.
Sure, sure. And, you know, live loading, even, I mean, this consolidation step is very critical. Live loading will help in other areas too. Helps a little bit in consolidation, but boy, it really helps too if you are any of these other type of errors. Sometimes the live loading will also help us on that. You might actually make that another whole webinar because you're right. There's a lot of discussion when we talk about live loading. Now, something that I'm very a big proponent of is to look at these steps, these maintenance steps, as part of a continuous improvement program. Because really, I run into a lot of places where their culture at the plant is, you know, packing is easy, packing is very simple. Valves, packing is packing. Valves are going to leak, and really, that's not true. These steps are very critical, have to be spent a lot of time working on, and really get together more on these fact-based ideas instead of these old mindset that just is false. One of the best ways to do that is to create a multiple function team and really focusing on one solid goal, like reducing the number of valve leaks at a plant. And you can start looking at, as I said before, looking at the failure modes of the packing coming out. Have a team that gets together and goes through those bags and say, oh, this many percentage are damaged because they're extruding and there's a valve problem. This many are poorly cut. We should train people on how to cut the rings properly. There's this many that people put the wrong packing in the wrong place. We should have giant signage in the storage room to help people select which packing goes where. Those really help in a lot of regards to get these things to work better. So as I said, reducing when the wrong product is installed, streamlining the storeroom, that really helps too about using visual aids for that. And I've seen many plants who really put this as part of changing their culture get drastically better overall leakage in a plant. And Cameron and I were just looking at some of the stuff when we're talking about methane leakage, for example, in the United States. And someone had done a calculation that there are billions of dollars every year that are lost through valves that are pumping that have methane through the pipe just from poor installation of the packing or the packing leakage through there. This is one of those things that focusing on installation and those type of things, keeping the process in the valve and in the piping is a serious cost saver. And a lot of people, it's like money is just going out of the valve through leakage. It's another thing that can be added as part of this process and really see the whole difference in price of to do this.
Yeah, and among all the technologies where you can begin to recapture some of that product, because this is what you sell, this is going to be a pretty cheap one. It's mostly training. It's just putting the right product in the right places. It's not getting a new, more expensive, efficient flare or doing a green completions on wells. So this is an easy victory.
Exactly. So some of the things I just mentioned in the previous side, right? One of the goals would be to lower packing leakage rates. As I said earlier, cross-functional team of all factors, not just maintenance, but you also have engineering, instrumentation, and control. Some of those people are usually sometimes also installing the packing and like control valves. Basically have everyone who's involved in this, even operators, is a very important piece too, to be at the table and work together. Look at all packing failures, as I said, using the bags and then creating a matrix of how they fail and how to put training together to stop those issues. And really, the key is root cause. There are creating a very good root cause program here really makes drastic change, and I've seen some plants do some very good things by focusing on this. And just really quickly too, when we start talking about training, training has changed a lot in the last 10 years using adult learning principles and using a blended strategy. So we actually have more hands-on and other ways to do this, especially when we started talking about the four steps we just mentioned. When we talk about cutting rings, we talk about installing the rings, lubrication, and torquing. All four of those, really it's important to have people do them over a training session and actually can do them by their own hands-on and can see how well they can be done. Another thing I've also seen where valve packing installation sometimes happens during outages, and the contractors aren't trained on the procedure as much as the people inside the plant. So you have issues with looking at the data. Sometimes valves that are done by contractors that aren't trained, these same issues pop up because they're thinking all valve packing is very easy. That comes back to criticality, and another important point here is so many people, if they all install valve packing lackadaisical, they'll install it on critical valves. All LDAR valves are critical because they can add to penalties and fines if they leak. So it's very important that you kind of do a criticality matrix, and the valves that are most important, extra time is put to them to be installed properly. I've seen that many a times where you ask someone when they had this major failure and they had to bring a plant down, or they had a terrible fine for it, or had to have someone come in and shoot it, and you go, hey, who installed this? And I asked the guy, I said, did you know this was a valve that can bring the plant down? And the guy goes, no, I didn't. I installed it like I install all valve packing. And the valve before that he installed was like on a water line, that had nothing at all to do. So it's very important here too, is to kind of express to people and kind of looking at what is the most critical applications, and the time and effort for those compared to other applications surely can be important. So I've seen that also. So just to go over again, these are pretty much the steps that we covered: measuring, inspection, installation, consolidation, continuous improvement, and training. All are really important steps. And with that said, are there any questions over this webinar today? And if you have a question, just type it in the box over in the chat area below Cameron and I's smiling faces, and we'll answer them right here, right now.
Yeah, I also know that some of you guys might have come in a little late, coming halfway through. We recorded this so we can send this out afterwards. You probably put your email in as part of registration. If you didn't, you can put that in the chat box. We'll make sure to include you. Or you can always contact Ron or I either through Chesterton.com. There's a contact link there, or both of our emails are first name, a period, and our last name at Chesterton.com.
That's correct. With that said, I see some other people have joined, but they might have joined late and might have missed it. As good point, we will have the recording. We're going to send it out to everyone on that. Let's see here if we're getting any questions.
We're going to also take this opportunity to plug.
Yes.
We're doing a few more webcasts. We're doing one in 2 weeks, I believe, and that's going to be on actual testing. So we talked about testing protocols. If you are maybe confused or you want to know a little bit more about the difference between API, the API or the ISO or ISA has one, what TA Luft is. We're going to be covering all of that, and we have our own valve testing facility here, so we have some personnel that I think will be joining us that know quite a bit about this, because that's what they do every day.
Right. We're going to have
Ron,
one after that too. That's also going to be more. Going to have even more stuff, and almost another kind of wrap up on emissions in general also. So we're really putting a lot of effort into this, and because you signed up for this one, of course, you'll find the same announcement. We'll be sending out announcements for those also in the next couple of weeks.
And also, if you're interested, the FSA is doing a webcast on Monday, and we're proud to have two Chestertonians in that, one of which is Ron, and the other which is one of our engineers, Phil Mahoney. So that's going to be another great one. You guys should absolutely check that out.
Yeah, it's a week from Monday, so it'll be great, and we're very excited about it. And that one's actually going to be on. We're going to talk a lot more about how the new EPA regulations and how they break down and what they're talking about regarding valves and the sealing of valves, especially in methane regulations-wise. And you can see more of that at fluidsealing.com, which is the FSA website. So, with that said, we'll put this. We're actually going to have this video put up on YouTube, and we'll send everyone the link by Monday. So, with that said, thanks everyone, And Cameron, I want to thank you very much for being my co-host and one of many. And thanks again, everyone.
All right.
Bye-bye.